All right, now, the conservation of momentum is a very important concept. And you have seen the conservation of momentum in work. How many people have ever gone bowling? Bowling, okay. You take that ball, okay, and you throw it on the lane, and it hits the pins, and the pins go wild. The ball goes in the gutter. It eventually comes back, right? But all the momentum that the ball has, the mass of the ball, which is significant, the velocity of the ball, all of that momentum exists just before it hits those pins. It hits the pins go all over the place, the ball keeps rolling. But what happens to all of that momentum that the ball had? Well, some of that momentum is transferred to the pins. The ball keeps some of the momentum because it's still moving forward, but the momentum of the bowling ball, the momentum of the bowling ball before the collision, correct? Plus the momentum of the pins before collision, yes, will equal the momentum of the bowling ball. I meant to put ball here. After collision, plus the momentum of the pins after the collision. Correct? So, but before the collision, what's the momentum of the pins? Before the collision, what is the momentum? Zero. That's right. They're not moving. So that's zero. So all the momentum is here, correct? Let's say it's 100. Okay? So 100 plus 0 is 100, correct? And then let's say the ball has only 20 left. How many does the pins have? How much momentum does the pins have? It has 80, right? I heard you, that's weird. It has 80, correct? So, the momentum before the event equals the momentum after the event. You get it? Okay. Easy? Okay, now, let's say I have a very small locomotive. You know what a locomotive is? Train, locomotive, right? I have a very small locomotive. Let's say that locomotive has a mass of 1,000 kilograms. Small locomotive. Small locomotive, 1,000 kilograms. Okay? You all right with that? Let's say that locomotive is going 5 meters per second down the tracks. Okay? That's the velocity. Now, what's the total momentum that locomotive has? It's going to be 5,000 kilogram meters per second, correct? Yes or no? 5,000 kilogram meters per second. And now it sees a moose on the tracks. Giant moose. Now moose are very large creatures. Let's say this moose is 500 kilograms, right? And he's just sitting there. Sitting there. He's just sitting there, right? The velocity is 0 meters per second, but he's just sitting there, correct? What momentum does the moose contribute to the before collision? What momentum does it contribute? Does it have any momentum? Yeah, 0. So this is 0, right? All right, now the train hits the moose, but there's what we call a cow catcher, and the train scoops up the moose. Moose is fine. Moose lives. Very important. No animals were injured while doing this problem. Not a problem. They call them cow catchers. And the moose gets on the train, correct? Yes? You get it? So now it's going to be the mass of the train, and they're together, correct? Plus the mass of the moose. You all right with that? It's together. And then it's going to have the train moose, right? You get it? So, here's the train, correct? Here's the train. Moose is standing still. Now, the moose and the train are now together as one thing, correct? What is going to be the velocity of the moose train system? What is going to be the velocity of the moose train system? If momentum is always conserved, what is going to be the velocity of this moose train system? All right, I know what it is. This is 1,000, this is 5 meters per second, and that's 500, right? So what I'll do is, I'll erase everything, okay? And I'll say 1,000 kilograms times 5 meters per second, correct? Yes? Plus 0, right? You okay with that? Equals, this is 500 kilograms, right? It's 0 because the moose isn't moving, correct? Right? Okay. So this is going to be 1,500 kilograms times some velocity, but it will be the train moose system. You got to think system. What's the system? Clear? So this is going to be 5,000 equals 1,500 V. So what's V equal? What is it?
3 meters per second.
3 meters per second. 5,000 divided by 1,500 is 3. Really? I think you're taking some liberties with rounding. What is 5,000 divided by 1,500? So it's going to be the velocity of the moose train system see that? Make sense? Al-Haji, you okay with that? Wait, question, hold it. Yes. What do you need? The question is, where do you get this from? Where do you get that from? Well, you understand the train is 1,000 kilograms, right? Right? There's the moose. The train is going to scoop up the moose, and now it's the train and the moose traveling together. Right? Yes? The 1,000 kilogram train was moving 5 meters per second. Correct? It's bringing 5,000 kilogram meters per second into the system. Yes? It's going to pick up that moose. Correct? Yes? And it can't lose momentum. How do you know that? Because what is 1,500 times 3.3? What is it? What's 1,500 times?
It's 5,000.
5,000, yeah. See? These are equal. So this is before the collision. This is after the collision. This is 5,000, right? But instead of 1,000 kilogram train moving 5 meters per second, you have a 1,500 kilogram train moose going 3.3 meters per second. You get it? Sure. Okay? That's it. Conservation of momentum. It's a pretty simple one, but it's still good. It still demonstrates the concept of the conservation of momentum. Understood?